All right, in this lesson, we're going to continue working with function families. We're going to actually review another function that we've already learned about, which are exponential functions. If you remember, this was what we did back in Unit 5. So just to review, we're going to start with this do now question. It says the graph of the equation y equals 2 raised to the x power intersects which of the following axes. So let's take a look at what that graph looks like. This should be what the graph looks like, just to demonstrate how to type these exponential functions in. After you type in y equals, you would do 2, and when you want to raise something to the x power, you're going to hit this button on the left side here that says a to the b, and you'll notice then that it kind of jumps it up to the top, and you can type in 2, and then you put your x up top there. So this is what your graph looks like. So if you notice right here, it does intersect the y-axis. However, what's happening here on the left side is that your graph gets really close to the x-axis. It gets so close that it looks like it touches it, but it does not. So for this do now question, the answer should be choice 2, because our exponential functions only cross over the y-axis. They get really close to the x-axis, but do not actually touch them. So for this lesson on transforming exponential functions, we're going to be back in our packet function families part 1, starting on page 3. So we're going to kind of explore what happens when we transform these functions before I just tell you the rules. If you remember back in Unit 5, we learned that one of our parent functions, or our original functions, was y equals a times b to the x. So we're going to be comparing all of these to that original function. So you'll notice in activity A here, I'm going to be changing the a value. Some of them are positive, some of them are negative. So if you took the time to graph these, this is what the graphs would look like. Notice that I've already graphed all 4 down here, and I labeled which one is which. So just to summarize some of the things that we notice, what I notice first is that these last 2 functions here with the positive a value, those are these graphs up here above the x-axis, whereas these 2 values over here with a negative a value, those are these 2 graphs down here below the x-axis. So something that I can summarize is that if a is a positive number, that means that our graph is above the x-axis. Okay, so again, those are those 2 graphs that we see up on the top here. However, in the bottom 2, we see that when our a value, that number out front, is negative, that means that our graph is below the x-axis. So that's one way that we see that that value of a out front can transform our graph. It can either have it be above the x-axis or reflect it down below. The other thing that I notice here is that 2 of these a values were 0.5 and 2 of them were 2. So how does that affect our graph? Well, if we focus on these 2 positive ones on the top, the graph of 0.5, notice that although it rises and it moves up, it doesn't do that as quickly. It's not as steep as this graph right here with 2 times 2 to the x. You'll notice that that graph does go up a lot quicker. So something else that we can summarize is that when we have an a value of 2, that means that the graph is more steep. Which again, what does that look like? That means that it rises quicker, meaning it goes up closer to the y-axis a lot faster. Okay, and that's more steep than when the a value was 0.5. So we see here that the a value can basically do 2 things to the graph. It can make it be either above or below the x-axis, and it can make the graph more or less steep. Let's take a look at activity B. You notice in activity B here that we're going to be changing our b value, our a times b to the x, or our base. So let's see what those 2 graphs look like. If you were to graph those 2, they would look like this. Our 0.5 is coming down, whereas our 3 to the x is coming up. So the way that we can summarize the change here is that when our b value was 0.5, our graph is decreasing, or a word that we like to use with exponential functions is that it's decaying. So these graphs look like this. They fall from left to right. They go down. However, when our b value was 3, that's when our graph was increasing. It was going up from left to right. So you'll notice here that when our b value is going to be a small decimal number between 0 and 1, such as 0.5, our graph will be decreasing or decaying. Whereas when our b value is a number bigger than 1, such as 3 in this example, our graph is increasing. And let's take a look at part C here. This is the last way that we're going to transform our functions. You'll notice here that we're adding sort of a new number to the end here. And this is actually a new variable that we're going to introduce, which is called the k, or a constant value. So let's see what these three graphs look like. So here on the graph, you see our original 2 to the x right in the middle right here. And then you see 2 to the x plus 3 up here, and 2 to the x minus 3 down here. So if you'll notice, when I added this 3, that moved our graph up 3 units. So I'm going to say that the plus 3 moved the graph up 3 units. However, when we put this minus 3 at the bottom, you'll see that now our graph moved down 3 units. I didn't change the steepness or anything else. It just literally moved the graph straight up or straight down. So you'll notice here that now when we put a constant number on the end, if that number is positive, it moves the graph up. If it's negative, that moves the whole graph down. So all of these results are summarized in this table on page 4. You'll notice that the setup of this chart is the exact same setup as our linear functions. So again, today we're talking about our exponential function family. This is our parent or our original function, y equals a times b to the x plus or minus k. So our original graph here of y equals, I believe this was 2 to the x, would look like this. Our domain is all real numbers because I could have any x value I want, but our range is just y is greater than 0 because our y values are all positive but not including 0. So you'll notice in our chart here, just like we found in our 3 activities, there's 3 different ways you can transform this function. If you change the a value, that can either make your graph below or above the x-axis, depending if it's negative or positive. And the larger that number gets, so -3, -4, +3, +4, that stretches our graph, which makes it steeper. But if our number is between 0 and 1 or 0 and -1, meaning like a small decimal number, that's going to compress our graph. And that means I kind of smush it down, it becomes a bit wider. So again, our a value can either move the graph above or below the x-axis, or it can change how steep or stretched out the graph is. In our second activity, we learned that we can make the b value do one of 2 things. If our b value is between 0 and 1, again, meaning that it's a decimal, we know that our graph is decaying or decreasing, meaning it's going down. If our b value is greater than 1, so 2, 3, 4, any other number, that means our graph is increasing. And it says as b increases, the graph rises more quickly or gets steeper. So 2 to the x, then 3 to the x would make it steeper, 4 to the x even steeper, and as the numbers increase, the graph would get more and more steeper. And finally, our last new variable we introduced, our k variable, or that constant on the end. If we add a value of k, that shifts the entire graph up. If we subtract a value of k, that shifts the entire graph down. So again, you can see in this lesson here that there are 3 different ways that you can transform your exponential functions by changing a, b, or k. So let's take a look at our guided practice. For all of these questions, we're going to be comparing them to the parent function 2 to the x. So looking at part A, what I noticed that they changed here is that they put this extra number out front, an extra 2 out front. So that means that our a value is 2. So looking back at our chart, we know that if our a value is positive, that means that the graph is still above the x-axis, but now our graph is being stretched. So here the graph is undergoing a vertical stretch, which what that looks like to us on the graph is that it's steeper. The graph would rise more quickly. Looking at part B, the change that they made here from the parent function is putting this -2 at the end. We know by comparing that to our new parent function, that means we have a k value of -2. And we know that if we put a k value that is negative, that moves the whole graph down. So the transformation that happened in part B was that the graph was moved down 2 units. Looking in part C, we notice we again went back to changing the a value out front. Now we made our a value 0.2. So our a value is still positive, it's still above the x-axis, but when we have an a value between 0 and 1, one of our decimal numbers, that means our graph is being vertically compressed or kind of smushed closer to the x-axis. So here for part C, we're going to say that the transformation was a vertical compression. And finally, looking at part D, we notice here that now we actually change that base number. It's no longer 2 to the x, but instead our b value became 0.2. So what we notice from our chart that summarizes our transformations is that when our b value is a decimal, the graph is no longer increasing, but now our graph would be decaying. So the function transformation that happened in part D is that the graph is now decreasing, or again, the word that we like to use when we're dealing with exponential functions is decay. So again, the 3 ways that we can change our functions are by changing our a, our b, or our k. If you're not sure how to memorize all of these transformations, you can always just graph all of the functions at the same time and see how they look different. So let's take a look at our checkpoint question. Try to pause the video and answer this. It's giving you here a parent function of 3 to the x, and they want you to match up 1, 2, 3, and 4 with the transformations given in A, B, C, and D. So go ahead and take a moment to try that. Okay, so comparing these functions, starting with number 1. In number 1, the transformation that happened here is that our b value became 0.3. So we know that if our b value becomes 0.3, that means that our graph is now decaying. So for number 1, you should have said choice B. For number 2, we notice that they put a 0.3 out front. That means our a value is 0.3. So our graph is still going to be above the x-axis, but we know that if our a value is 0.3, it's not going to be as steep, which means the graph has been vertically compressed. So number 2 should be choice A. Looking at number 3, we notice that they put a positive 3 on the end here. That means our k value is positive 3. We know from our notes that if a k value is being added, that means that the entire graph is shifted up. So number 3 should be choice D. And finally, for number 4, they went back to A, their a value, and they changed it to 3. We know that if the a value becomes larger and larger, that makes the graph more stretched out, which makes it steeper. So number 4 should be choice C. So for our independent practice here, if you weren't able to match any of those correctly or only one, please start with the red questions. If you were able to get either 2 or 3 matched correctly, please start with yellow. And if you had all 4 matched up correctly, please try the green questions. Go ahead and try these problems and come back and check your work. Okay, so let's go ahead and take a look at our answers. Feel free to pause the video to check your answers. Here's numbers 1 through 3 on page 4. Numbers 4 through 8 on page 5. Numbers 9 and 10 from page 5. Numbers 11 and 12 from page 6. And numbers 13 through 16 on page 6. And now that you have finished this lesson, again, if you have any questions about any of this, please email us to set up a time for extra help. You now can go back to your exit ticket 9.1 and you should be able to answer question number 2. You also can now answer question number 2 on homework 9.1 as well.